All right. So we're going to step forward just a little bit. So we're going to be talking about the graph of tangent. So let's little info dump here. So the parent function for the set of all tangent functions is just y equals tan x. Now, you might remember that tangent can be undefined. So the domain is the x's that are not equal to n times pi over 2, where n is an odd integer. So, for example, odd integers would be things like, what? 1, 3, 5, 7. Also, -1, -3, -5, -7, etc. That too. The range is going to be all real numbers. So the graph has this odd symmetry, that's that 180-degree point rotation about the origin, which is a mouthful, why we just call it odd. Its midline would be y equals 0. Its period is going to be pi, so its frequency is 1 over pi. Note here, though, the fundamental period for tangent is different than the fundamental period for sine or cosine, right? Sine and cosine, it's 2 pi. Tangent, it's 1 pi. So just be careful about that. It's easy to get turned around on that. Okay, let's just take a look at the graph of this on our calculator, just to kind of get a picture of what this bad mama jamma is going to look like here. If I just graph tangent of x, you can call these wacky lines, sure, I guess. Everybody's okay with this? So, a couple of things I notice is it looks like there's vertical asymptotes, right? Everybody see that? Those are corresponding to the locations where the x's aren't in our domains, right? So the question becomes, how should I think about tangent? Well, if you guys recall from our naive right triangle definitions, tangent is opposite over adjacent, right? Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. One other way that we can describe describe tangent is as sine over cosine. Why does that work? Well, I know sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And when I divide those two fractions, I can make a reciprocal and turn it into a multiplication problem. Hypotenuse cancels out. And I get that that is equivalent to opposite over adjacent, which is our definition for right? So using this idea, let's ask a couple of questions. So when is the tangent function undefined? Well, the answer is whenever it has a zero denominator, right? And since cosine is the denominator, it's going to be undefined when cosine is equal to 0. Everybody's okay with that idea? And if I recall, for cosine x equal to 0, x could be pi over 2, 3 pi over 2, etc. i.e., we have pi over 2 times n, where n is an odd integer. Or you could think about it as pi over 2 plus n pi, where n is any integer. So either way of thinking about that is okay, but it basically means the same thing, right? Zero denominator is what makes it undefined. This means where n is a member of the integers. That combination of symbols anyways. Ben, what do you specific? I'm still not clear what your question is.
At the IE, I thought that was n. The 2 on the denominator.
Oh. Yeah, that's a 2. My next question is, when is tangent equal to 0? That's incorrect. It's a fraction. Tangent is a fraction, right? So it's equal to 0 whenever the numerator is equal to 0. So the answer is whenever sine is equal to 0. So if I recall, those values of x were like 0, pi, 2 pi, etc. Or zero plus n pi, where n is a member of the integers. Okay with that? Okay. So if we're going to graph a tangent function, we're going to be real interested in reference points, right? So if I think back to what this graph looked like, what I'm going to do is I'm going to look for one section of this graph. So say I'm looking at this middle section here. So I'm going to want an asymptote, a point on the lower arm, a point on the midline, a point on the upper arm, and then another asymptote. Everybody okay with that? Okay. So specifically, the points that I want on those arms are going to be pi over 4, because what is the tangent at pi over 4? 1. That's just convenient to graph. And then I'll also use negative pi over 4. What is the tangent at negative pi over 4? Negative 1. All right, so let's record all of this now. So negative pi over 2, undefined. Negative 1, 0, 0. Pi over 4, positive 1. And then pi over 2, undefined. Those are going to be the reference points we'll use for tangent. Yeah, when we want to graph tangent, these are what we'll transform to get our new function. Apparently today I am. So let's do a graph. So let's say we want to graph negative tangent of x over 2. Just like we've done, I'm going to start by rewriting this so it's easy for me to pick out my values for a, c, h, and k. So I get a is negative 1, c is the reciprocal of 1/2, or 2, h is 0, and k is 0. So from this, I could list my amplitude. What's my amplitude going to be? That's a trick question. Tangent graphs have no amplitude. Why not?
Because it's not amplitude.
Well, the amplitude is the distance from the extrema to the midline. That distance would be infinite, right? So there's no, because there is no global maximum. My period, though, is going to be pi times the absolute value of c, or 2 pi. My midline is y equals k, so that's y equals 0. And then my frequency is 1 over the period. So to graph this, I'll make a transformation map. As always, my transformation map is cx plus h, ay plus k. That part never changes. The only thing that does change are the values for a, c, h, and k, as well as the key points that we're going to be transforming. So here, my transformation map is just 2x and then negative y. So let me copy down those reference points. And these ones are usually pretty easy to remember because they're so symmetric, right? Totally symmetrical, dude. All right, so when I plug negative pi over 2 in for x, I get negative pi. What happens when I negate undefined? What's that going to be? Still undefined. So that's going to become then negative pi over 2 and positive 1. 0, 0. That's going to become positive pi over 2, negative 1. And then the last one's going to become positive pi and then still undefined. Is everybody okay with that? Sure. It's like a Billy Joel song here. That's so busy graph. Because it's for the longest time. That was the Billy Joel joke I was making. Some good doo-wop Billy Joel there. All right, you guys ready?
Yeah.
All right. So let's make an XY axis here. So I'm going to graph mine from negative 2 pi to positive 2 pi. All right, so at negative pi, I have an asymptote. Negative pi over 4, or I'm sorry, negative over 2, I'm at positive 1. Then I have 0, 0. And then I have positive pi over 2, negative 1. And then I have an asymptote. Everybody okay with that? Yes. They're literally on my list. Okay? So, stop talking, please. Yeah. Yep, just one moment. So there's me filling the space. Ben, is that good?
Okay. I was just confused with how you got those points, but I see.
Just use my transformation math. All right. One more kind of problem we should talk about here. And that's being able to go from a graph of a tangent function to an equation. So let's say we have this one. Can you guys stop throwing things? Would you stop getting hit by things? All right. So let's look at this graph. My goal is to be able to write a tangent function that looks like this. So I need to determine my values for A, C, H, and K. Everybody okay with that? So first thing I'm going to do is the easy one. I'm going to find my K. Well, that's my midline, right? So what's that tell me K is? Negative 1. Everybody's okay with that? My period is going to be just from asymptote to asymptote here. So in that case, I have pi minus negative, or pi over 2 minus negative pi over 2, or just pi. So what does that tell me about, oh, sorry, those aren't pi over 2s, those are pi over 4s. So that's pi over 2. So that tells me that C is 1/2, or absolute value C is 1/2. Remember that the period is equal to pi times C for tangent rather than 2 pi times C. Got to make sure you remember that. It's a common mistake students make. They just get going too fast. You don't got to go that fast, though. The next thing I'm going to do is determine my value of A. So if I look at halfway between my midline point and the asymptote, the distance from the graph to the midline is going to be my value for A. In this case, that value is 1. I looked at halfway between my midline point and the asymptote, and I looked at the distance from the midline to the graph. So just looked at this distance right here, which is 1 unit. We're just visualizing it. You could have gone and looked at this side as well. So that's the distance from the midline point to the asymptote. So halfway, and then I'm going to look to the graph, and I'm looking at how long that piece is, which is just 1 unit long. I can just read it off the graph, right? Because I'm going from -1 to -2 on the y direction. Does that feel okay? The last thing that I'm going to need to find is my h. So for tangents in the parent function, I have a midline point at 0, 0. And on my transform function, I have a midline point at 0, -1. But I have to be a little bit careful about my midline point here. I have to look at what's surrounding it. So if I look in my transform function, here's my midline point. To the left of it, I have the graph pointing down. Everybody agree with that? To the right of it, I have the graph pointing up. Agree with that? Okay. Let's check the parent function as to what's going on. So here we have the midline point here is 0, 0. To the left of it, our graph points down, and to the right of it, our graph points up. That matches. Everybody agree with that? So that tells me that A is just 1, C is just 1/2, and then to find my H, I can do this same thing, use my transformation map. So I have C times 0 plus H equals 0, or H is equal to 0. If I put that all together, I have 1 times tangent of 2, the reciprocal of C, x minus H plus K. Or really just y equals tan of 2x minus 1. Okay with that idea? And as usual, I can check these pretty easily. So if I wanted to, I could graph tangent 2x minus 1. And I want to graph this on the same viewing window that I'm looking at here. So to me, that looks like this is -3/4 pi. Do you guys agree with that? If that's -1/2 and that's -1/4, this must be -3/4. You agree with that? So -3 pi over 4 is going to be my y min. Over here, it looks like this is 5/4 pi. You agree with that? So I'll do 5 pi over 4. And if I look at my, and then we're going up by quarters, so let's make our increment pi over 4. If I look at this, it looks like we're going from -5 to +3. And our scale is just going by 1s in the y direction. So let's hit graph and see if this looks like what we got here. Boy, I'd say that's pretty good, right? Looks just like it. Short of having the asymptotes drawn in there for me. Does that feel okay with you guys? Well, that's all I want to do. Yeah, I think so too.